See, from the temperature to hot is 200 degree. Yalah bakpao. Hello everyone, come back again with me on third Koniago channel. Today in this video I will show you how to analyze this heat exchanger like this. And without wasting time, let's start it. First, make this part transparent like this. See, after that go to Solidworks add-ins, active Solidworks flow simulation, go to flow simulation, go to tools, click create leads, click this phase, this phase, this phase, and this phase. Click OK. And after that, we check the leak. Click check geometry. Choose analysis type is internal. Click check. See, no leak. Close. Now active wizard. Main project name is CFD Heat Exchanger. Click next. Choose finish system is SI. Go to temperature. Change temperature unit to Celsius. Click next. Check fluid flow. Check condition. Check gravity. In Z axis is 0. In Y axis is 9.81. Choose analysis type is internal. Uncheck this. Click next. Choose fluid diffuse is air and water. Click add. And go to liquid and choose water. See? Click next. For diffuse solid, go to alloys. Choose stainless steel. Click next. For wall condition, in adiabatic wall, change to heat transfer coefficient. Heat transfer coefficient parameter make 30. Click next. And finish. See, hide competition domain, insert fluid subdomain, click this phase, fluid type change to liquid, make temperature 200 Celsius. And click OK. Active fluid subdomains again. Choose this phase. Change fluid type to liquid. And change temperature to 15 degree. Click OK. Now we insert boundary condition. Click this phase. Choose inlet mass flow. Make mass flow rate is 1 kg per second. Click OK. And change the name hot inlet. Okay. Insert body condition again. Click this phase, change to environment pressure, click OK. Change name to hot outlet. OK. Active boundary condition again. Click this phase, choose inlet mass flow, change to change mass flow rate to 0.5. Okay. Change the name to cool inlet. Active boundary condition again. Click this phase, check environment pressure. Sorry, not that phase. Click this phase, and then in the temperature 15 degrees Celsius, and click OK. See, and change the name cold outlet. Okay. See? After that, insert goals. Insert global goals. Choose velocity. Check max. We will search max velocity. Click OK. Change the name to max velocity. Insert surface goals. Click this phase. Check temperature fluid in average. Click OK. Change the name to outlet temperature. Okay. Then insert surface goals again. Click this phase. Check temperature average. Okay. Change the name to hot inlet. Sorry, hot outlet. And this name hot inlet. Active surface goals. Check this phase. Check temperature average. Click OK. Check the name to cold inlet temperature. Active goals again. Check this phase. Click temperature flow average. Click OK. And change the name cold outlet. See? Now our goals is done. Now we mesh the design. Click globalness. We choose average 3. Click OK. And run the simulation. Click run. Just waiting. See, the simulation is done. Now go back to Solidworks to see the result. Choose cut plots to see the result. Choose from plan for parameter. Choose contour. Change to temperature. And click OK. See? In hot outlet temperature, the fluid temperature is in low, maybe in 115 degrees Celsius. Let's see and use a probe. See? The hot outlet temperature is 159 degrees Celsius. And cold outlet temperature is 65 degrees Celsius. Hide this result. And now go to flow trajectories. Click this phase. Change to number point parameter is 50. Choose line. And click OK. See? Now, let's see the goals. Go to global goals. Check all goals. Click show. See, Vmax value is 0.52 meter per second. For inlet temperature value is 200 degree. See, for hot water 200 degree. Change to 158 degrees Celsius, and from cold water 50 degree, change to 36 degrees Celsius. I think it's the end tutorial. I hope you like and can learn Solidworks use my video tutorial. Thanks for watching. See you in the next tutorial. Bye bye.